Okay, so I thought I'd work through a few of these homework problems on page 149, and I'll just do this on paper with sort of just the talking hand version. So, also in the text, you're asked to graph this over a 2-period interval. I think it is sufficient to graph it over a single interval. So I'm going to graph this function, y equals sine of 1/2 x over 1 period. So we're going to graph 1 period of this function. So first, what is the amplitude? Remember, the amplitude is the absolute value of the coefficient. If there is no coefficient, we assume it to be 1. Remember that when you compute amplitude, you should always compute absolute value. So in this case, the amplitude is the absolute value of 1, which is 1. Also, we need to bear in mind, so far we have 2 basic shapes. The first basic shape is the sine curve. So that's the basic shape of the sine, and this is the basic shape of cosine. Now that's all the detail you need if all you're talking about is the basic shape. Similar to if someone asked you to draw the basic shape of the square function, you draw something like that. You wouldn't need all the detail to understand that this is the basic shape square function. If someone asked you to draw the basic shape of the absolute value of something, you'd put something like this. You don't need the detail, you don't need complete accuracy. This is just the basic shape absolute value. This is the basic shape square function. Well, this is the basic shape of the sine curve, and this is the basic shape of the cosine curve. So, our amplitude is 1. We need the basic shape. The basic shape is the sine curve. So just sketch out the basic shape. So whatever our picture looks like, it has to look something like this. Now the key element here, there is a change of period. So the rule we're using is this, or the procedure we're using is this. Start with 0 to 2 pi, which is the standard interval for the sine curve. But in here, in between, you don't put x, put 1/2 x. So take the quantity that is inside the parenthesis, the argument of the function, that goes between 0 and 2 pi in this extended inequality. Now, solve for x. So what that means is multiply everything through by 2. So this gets multiplied by 2, multiplied by 2, multiplied by 2. So everything gets multiplied by 2, and that produces 0 less than or equal to, the 2 and the 1/2 cancel, less than or equal to 4 pi. So when we graph 1 period of this function, it's going to go from 0 to 4 pi. So, it's going to be fairly lengthy. Try to make it reasonably accurate. So if this is 1 and -1, then about 3 times as long, approximately, that's pi. I just approximated this is 1, so I counted out 1, 2, 3, and a little bit more, that's pi. If that's pi, this is 2 pi approximately, this is 3 pi approximately, and this is 4 pi approximately. All right? So, this sine curve basic shape has to fit in this interval. Remember that what we're going to do is plot the 5 basic points, and we need to take this interval and divide it into 4 equal pieces. Well, in this case, that's already done for us. It's already divided into 1/4, 2/4, 3/4, and 4/4. And so we place the basic points in their relative position here. Sine starts at a node. On the first quarter, it becomes the peak. The second quarter, it becomes the node again. The third quarter is the trough at -1 in this case. And the fourth quarter is once again at the node. So node, peak, node, trough, node. Roughly sketch the sine curve. Once you get these points played in, just make it look nice. And that's the graph of the function y equals sine 1/2 x. That's a sketch of the graph over one period.